Alright, let's finish up on 4.3, 4.5 quiz review. This is the back page. So this is what's given to us. The definite integral of f of x from 3 to 7 is equal to negative 4. So now we want to use this property to find the definite integral from 7 to 3 of 2 f of x dx. Now I can pull the 2 out in front, and I can also change the bounds so that it matches what's given to us. But if I change the bounds, I have to pull a negative out. So now definite integral from 3 to 7 f of x simply gets replaced with negative 4. But then there's two negatives, which will cancel out to be a positive. And then this coefficient also gets multiplied through, so 2 times 4 is equal to 8. Okay, part B, definite integral of 3 f of x minus 2. We can split this up into two separate problems, but remember, this 2 is inside the definite integral, so we have to make sure that that we hold on, that we go through the appropriate power rule or appropriate rule for this value that looks like a constant. So I split this up into two separate terms, or two separate calculations. So 3 definite integral from 7 to 3 of f of x, which we know to be negative 4, okay, from what we positive 4. Because if we flip the bounds around, we get a negative, and the two negatives cancel out to be a positive. So 3 times 4 is 12. So that takes care of the first definite integral. The second one, though, definite integral of 2, so 2 becomes 2x. Plug the upper and lower bound in, so we get 6 minus 14, which is negative 8. So now we have 12 minus a negative 8. So 12 minus negative 8 gives us positive 20. Okay, number 7. We have to go through U-Substitution. We want to pick the U value so that our derivative will cancel out the remaining term. And if you see an inner function, then usually we want that inner function to be the U value. Okay, so in this case, our U value is 3 over x. If we rewrite it so that we can apply power rule, it will become 3x to negative 1. We go through power rule, derivative. So negative 3x to negative 2. Rewrite it using positive exponents. So cross multiply and solve for dx. So dx equals negative x squared over 3 times du. We make our substitutions. 2 over x squared does not get replaced initially. Secant of u, tangent of u. So both 3 over x gets replaced with u. And then dx gets replaced with negative x squared over 3 times du. Now we see that the x squared will cancel out, but we have to keep track of the negative 2/3, which comes out as a coefficient. So now we have something clean that we can find a rule for. So integral of secant tangent is simply secant. So negative 2/3 secant of u plus c. So negative 2/3 secant of 3 over x plus c, once we replace u in terms of x. All right, number 8. Okay. We can rewrite our problem as the definite integral of 5x times 2 minus x to the 1/2 dx. Okay. Once we see the rational exponent, we can see that identify the u value to be 2 minus x. Du over dx is negative 1. dx equals negative 1. We make our substitution. However, once when we make our initial substitution, the x does not cancel out. So we get 5x square root of, or u to the 1/2 times negative du. Okay. However, we can go through change of variable to replace x in terms of u. So we know u is 2 minus x, so x must be equal to 2 minus u. So we get integral of 5 times 2 minus u times u to the 1/2 times negative du. Distribute the 5 and the u to the 1/2 and the negative 1 through to get negative 10u to the 1/2 plus 5u to the 3/2. Okay. Everything is set for us to apply power rule. So negative 10u to 3/2 over 3/2 plus 5u to the 5/2 over 5/2. Bring up the fractions, combine terms, and then we have our indefinite integral. Finally, replace u in terms of x. Number 9, we see that we have one term in the denominator. We can split this up into individual terms. So no need for U-Substitution. We can just go through, rewrite this with variables separated by plus or minus, with both variables in the numerator. We go through the power rule. Okay. Bring the 2/3 and the 1/2 up. Evaluate between our upper and lower bound. Plug in our upper bound first. Okay. Minus, then plug in our lower bound. Then we can go ahead and simplify all these terms. Okay. All this reduces to be 2/3 times 27, 2 times 3, 4 to the 3/2 becomes 8, 4 to the 1/2 becomes 2. So combine these terms, and then we add fractions, or combine these terms with the fraction, we get 44/3. Alright, number 10, we can think of this as tangent of x squared times secant of x squared. So if we let u value be tangent of x, then we can find the derivative, which will allow us to cancel out the secant squared of x. So d over dx is secant squared of x. Dx equals du over secant squared of x. Make our substitutions. Tangent gets replaced with u. Secant squared stays. Du over secant squared, which will allow us to cancel out the secant squared. So now we have u cubed over 3. But because we went through U-substitution and we're doing definite integrals, we have to convert our lower and upper bounds to be in terms of u. So if x is 0, we can plug 0 in for our assignment. So tangent of 0 is going to stay 0. So initially we started with 0. Our new lower bound is still going to remain at 0. Okay. Our initial upper bound is pi over 3, so plug pi over 3 in for s. And we're going to get tangent of pi over 3, which is root 3. So our old upper bound is pi over 3. Now our new upper bound is root 3. So our antiderivative is u cubed over 3. Our new upper bound is root 3. Our new lower bound is 0. So plug upper bound first. So 1/3 square root of 3 cubed. Okay, that's f of a. Minus f of b. So plug 0 in for u. So that will just cancel out to be 0. So we simply need to simplify this term here. So 1/3 times 3 root 3. 3's cancel out, leaving us with root 3.